Hi guys, today we are going to be looking at what to do when we solve equations with variables on each side of the equal sign. But before you start today's notes, please pause this video, open up your agenda to Monday, November 28th, and please write down that tonight your homework it's a worksheet, and it's technically pages 12 and 13, which is section 5-2 from the book, and you are just doing evens only. So pause the video and go write this down in your agenda, and then come back to the video once it's written down. Alright, so in your table of contents, I don't have my math notebook with me, but in your table of contents, today's topic is solve equations with variables on each side. Today's date is the 28th, and once you have that written down in your table of contents, go ahead and turn to the next clean page in your notebook. Give it a title, the date, and the page that you are on. And once you're ready, we will begin. Alright, so we know that when we solve equations, whatever we do on one side, we have to do to the other. And what I mean by one side, I mean one side of the equal sign. And a quick reminder, whatever I am writing down in my notes, you are expected to be writing down in yours as well. And just like all of our other times when we were solving equations, our ultimate goal is to isolate the variable. Now the only difference this time is we are going to have the same variable, but on both sides. So things are going to have to move around a little bit. So let us start with kind of a simpler one, okay? Example 1. Okay, so example 1 says 3x plus 1 equals x plus 11. So the only difference here from what we're used to is that we see we have a term with an x over here on the left. We have this x over here on the right. So once I draw my line down the middle, which is a good indicator to remind myself that I have to do the same operation on both sides, I'm going to try and think, how can I get my x's onto the same side? Okay, so kind of in addition to isolating the variable, a goal with this is going to be move all variables to one side. Okay, move all variables to one side. So when I look at this problem, I have to think, is it going to be easier to move x or to move 3x? Ultimately, I should be getting the same answer if I do it correctly, but personally, I'd rather not work with negatives, so I'm going to take my value that's smaller and move it. So what I mean by that is I can't just poof move it. I have to do something to get it on the other side. So if I have a positive x on the right, I know that in order to cancel it out, I could subtract an x, because x minus x will cause these to cancel out. Whatever I do on the right, I must do on the left. So now I have 3x minus 1x, which will give me 2x, and everything else is going to come down. So now I have a two-step equation which you know how to solve. So I'm going to subtract 1 from both sides, bring down my 2x equals 10, divide 2 from both sides to undo this multiplication, and I get that x equals 5. Now just like always, I am going to substitute my value back in to make sure that I did this correctly. So 3 times 5, because that's what I think x is, plus 1 equals 5 plus 11. 3 times 5, 15, plus 1 is 16. 5 plus 11 is 16. And since 16 is equal to 16, I've done this correctly. Always go back to the original equation when you substitute values back in, because just in case you did something wrong with your first step here, I wouldn't want you to be plugging in, substituting in for an incorrect equation. So always go back to the original equation that you were given with to begin with. Alright, so that is how we go about moving variables to get them onto the same side. So let's do another. Example 2. C plus 18 equals 4 plus 5c. Alright, so I see that I have my variables, my terms with my variables on both sides of the equal sign, so I need to decide what I want to do to move them. And I just want to show you that you don't always have to move the smaller value, the smaller term. I personally find it more helpful, but that is your call. But I will show you what happens if I move my larger term with the variable. So in order to get 12c away on this left side, I can subtract, because I know 12c minus 12c will make a 0 pair. Whatever I do on the left, I have to do on the right. So everything comes down now. 18 equals 4, well 5 minus 12. 5c minus 12c will give me a negative 7c. And now I have a two-step equation. So in order to get all of my terms on one side and all of my variables on the other, I need to take away 4 on both sides. 18 minus 4 is 14. My negative 7c comes down. Don't forget, you always look to the left. My final step would be divide by negative 7 on both sides, giving me c equal to negative 2. So again, I decided to move the larger variable term, whereas in the first example I moved the smaller term with the variable. Either way, it doesn't matter as long as I'm doing my math correctly. Let's go ahead and substitute my value back in. 12 times negative 2 plus 18 should be equal to 4 plus 5 times negative 2. 12 times negative 2, let me move that over, sorry about that. 12 times negative 2, negative 24, plus 18 should be equal to 4 minus 10. Negative 24 plus 18, I know that those are 6 apart, more negative. 4 minus 10, negative 6. Does negative 6 equal negative 6? Yes, so I've done this correctly. Go ahead and write down the next example, and then I want you to pause the video and I want you to try it on your own. Once you've tried it on your own, I want you to resume the video and watch me go through it and see if you did it correctly. Okay, so here's your equation. 7y plus 25 equals 2y. Okay? So pause the video and go ahead and see if you can isolate your variable to solve for y. And then resume and see if you were right. Alright, welcome back. Hopefully you have an answer, and now you're checking to see if you did it correctly. I see that I only have a term with a variable on the right-hand side over here. So it's going to make my life easiest if I move the 7y. Because if I move this 2y, I'm left with 0, which is fine. I just kind of am making an extra step. So I am going to take away 7y over here. 7y minus 7y will make a 0 pair. Whatever I do on the left, I'm going to have to do on the right. This leaves me with 25 equals negative 5y. Divide both sides by negative 5. And that's y is equal to negative 5. How'd you do? Hopefully you knew if you were right, because hopefully you subbed it back in. 7 times y, which is negative 5, plus 25 should be equal to 2 times negative 5. All of 7 times negative 5 is negative 35, plus 25 is negative 10, and 2 times negative 5 is negative 10. So since those equal each other, I've done this correctly.